Pre-Cal babies. In this video, we are looking at Unit 9 vectors. Woot woot! Okay, so I've got your definitions and stuff already typed up, so you can read those and pause the video as you need to. But I'm just going to talk briefly through these. The vector, of course, is a line segment used to represent size and direction, and you can think of it as something like this. So here's my line segment. And every vector is going to have an initial point. Okay, and I'm just going to call that x1, y1. These are drawn in the coordinate plane, so they are ordered pairs. And then, of course, an arrow will indicate where the terminal point is. So this is also an ordered pair, and I'm going to designate it as x2, y2. All right, so our magnitude, of course, is our length of our vector, and since it is the distance between the initial point, oops, that did not work out as I planned. That's what I meant to do. It is the distance between our initial point and our terminal point. That means that we can use the distance formula, because the distance formula looks like this. It is the calculated distance between two ordered pairs, and it looks like this. So we take the difference of the x values and square them, and we add it to the difference of the y values squared. So that's how we're going to do that. All right, so equal vectors. These are vectors that are the same length and the same direction, but not necessarily in the same location on the coordinate plane. So let's say we had this vector right here and this vector right here, and they were the same. They, of course, would be parallel since they have to be going in the same direction. And then when we talk about the standard position, this is a vector whose initial point is the origin. So that would just mean that you would have something like this. Okay, so we could have a vector here, or it could go like that, or it could go this way or that way or whatever. But its initial point is always the origin. Okay, so the next thing we're going to talk about is the component form of a vector. So as this states, this is just an algebraic way to position our vector, and it will show its movement in the coordinate plane. So there's a particular way that we have to write component form. Component form of the vector is going to look like an ordered pair, but it's going to have, rather than parentheses, it's going to have these little pointy things here. They've got a name, but I can't remember what it is. And you basically take the difference of your terminal and initial x value and your terminal and initial y value. And essentially, it creates the values of movement, all right? And so what does that mean? Well, that means that the x value is going to move in this direction or this direction. So these will have signs, positive this way, negative this way, but it's also going to show the movement up and down for y. So that's going to make more sense when we start looking at these examples. So let's just jump on ahead here and look at example 1. We have an initial point of u, -1, 3, and a terminal point of v, 2 and -5. Find the component form of the resultant vector. All right, so if I want the component form, and notice this is letter u and letter v, so we indicate that this is a vector just like that. And so if I want the component form, okay, this one right here, that's my initial point. So that's x1, y1 here, and this is x2, y2. So for component form, I'm going to take x2, just like up here, so that's 2, and then it's going to be minus this x. Well, that's a negative, so make sure you're putting that in parentheses. And then for the y component, I'm going to have y2 minus 3. And then I am going to look at this. Remember, this is going to be 3, 2 plus 1. And negative and a negative, that gives me a -8. So that is the component form. So what does that mean? So let's talk about this. It means that if I'm going to position this vector in the coordinate plane, I am moving to the right 3 and down 8. So this would be my component, or sorry, my vector would be right here. Okay, so the component form just shows movement from the initial point to get to the terminal point. That's pretty much what it shows you. Okay, so we are going to look at these other examples in the next video because I don't want these to be too long.